Hi everyone. Sodium has 11 electrons, and so it has this electron configuration. Please note that this is not very stable because it does not have an entirely full valence shell. Its outermost principal energy level 3, is not full. So it's fairly unstable. That means it's fairly reactive. Uh, Many metals, especially alkali metals, are explosive in water, as we saw last week with sodium, potassium, and lithium. But it can become more stable by getting a noble gas configuration. It can lose this one electron and send it over to chlorine. And following that, it will have the same electron configuration as neon. Identical electron configuration. The outermost principal energy level 2, here is full. This is very stabilizing. It turns out that sodium will tend to lose an electron. It will tend to release an electron to get a noble gas configuration, but then that metal will lose electrons, but nonmetals like chlorine here will tend to gain those electrons. Here, that chlorine is not having a full valence shell. Yes, the 3s subshell is full, but the 3p subshell is not full. But if it gains that one electron, instead getting 6 electrons in the 3p subshell, then it will have a noble gas configuration. The same electron configuration as argon, and hence that will be very stabilizing. We can see that sodium, this very reactive metal, and chlorine gas, a noxious, poisonous gas, they will react and form something totally different, sodium chloride. A combination of sodium ions and chloride ions that together form table salt. Now, sodium or chlorine on their own could kill you, but table salt, unless you ingest a whole lot of it, it really is not that harmful. Totally different properties, having these different elements combined together into a compound. Also please take a note that when sodium released this one electron, it lost a negative charge. Originally there were 11 protons and 11 electrons, and there was no overall charge shown for sodium metal. But, after losing that one electron, it now has less negative charge than positive charge. Overall, there's a positive 1 charge for sodium ions. That's weird. You lose an electron, but you get a positive charge. That's because you lost a negative charge. So you become net positive, more positive than negative. And then chlorine originally had 17 protons and 17 electrons. But after it gains one more electron, it has 17 protons, but 18 negative electrons. There's one more negative charge here than positive charges. And so there's a net negative 1 charge on this ion of chlorine called chloride. So we can see some trends on the periodic table. Whether it's sodium or lithium or potassium or rubidium or cesium, the elements in group 1A will tend to lose 1 electron to have the exact same number of electrons and electron configuration as the most nearby noble gas. And so they will get a +1 charge. Then metals like magnesium or calcium or strontium or barium, those elements in this group 2A will tend to lose 2 negative electrons to get a noble gas configuration, so they will get a +2 charge. Noble gases do not tend to get a charge because they are already stable. They don't gain electrons or lose electrons. There is no net charge on noble gases. They don't get charge. Then halogens in group 7A, they tend to gain one electron to have the same number of electrons as a noble gas. Fluorine, chlorine, bromine, iodine will do that. So gaining a negative electron, they'll get a -1 charge. Oxygen and sulfur and selenium, those will tend to gain 2 electrons to have the same number of electrons as the most nearby noble gas. So for example, oxygen normally has 8 electrons, but it will gain 2 more to have 10, just like neon. So these elements will get a -2 charge. And then in group 5A, things like nitrogen and phosphorus, if they get a charge, they get a charge of -3. And finally, aluminum, gallium, those get +3 charges. We don't really observe charges in group 4A all that often. So we can predict the charges that certain things will have by their kind of place on the periodic table. So you actually can now mark on your periodic table. I would recommend that you mark that elements in group 1A get a +1 charge. You want to write a +2 here. Elements in group 2A get +2. Elements in group 3A get a +3. -1 in group 7A, -2 in group 6A, and -3 in group 5A. Please mark those on your periodic tables. You can have these marked for assessments this semester. Please take note that the periodic table is divided into 3 kind of overall general parts. Elements in this region are metals. Metals tend to combine with nonmetals, the elements in this region, to form ionic compounds. But also nonmetals combine with nonmetals or metalloids to form molecular compounds. That will be important as we get into the next video. But please take note that you might want to draw this in on your periodic table. I've sort of drawn in sort of step ladder here. So between boron and aluminum, a line, aluminum silicon, a line, line. The elements right alongside this step ladder are the metalloids. They're kind of the separation between the metals and the non-metals. All right, so right along here are the metalloids. All right, thanks for watching.